Okay, today we are doing notes 1.3 correlation coefficient. So first up, our learning target. I can analyze the correlation coefficient to determine the strength of the line of best fit. So we've already gone over how to create a line of best fit. Now we're just going to see how good or how strong that line of best fit is. So first step. So first step here, make a table. So sometimes it gives us a table, sometimes it doesn't. So we're going to make a table. I'm going to do it off to the side in this space over here. So I have all my data. So X, Y, and I'm going to fill it in. So this first point here is 174, and then 176, 282, 381. There's nothing for 4, 576. I know we're kind of getting off the screen here. 795. Extend this down. 988 and 1089. Okay, so once I have all those points written on this table, so you can see the whole thing. We're going to plug it into our calculator. So you always want to make sure you do home screen, new docs, don't save, and then add a calculator. So that way it clears out any old problems that we have. All right, best button in the whole calculator, menu. Move this up a little so you can see it. And then we're going to do stat or statistics. And then stat calc. And then we're going to pick mx plus b. So this should be review. If you're struggling with these steps, go back and watch the 1.2 video, and it'll help you there. So remember, X list starts with the squiggly braces, and then we need to type in this X list right here. So 1, 1, 2, 3, 5, 7, 9, 10. And I always check 1, 2, 3, 4, 5, 6, 7, 8. 8 things. 1, 2, 3, 4, 5, 6, 7. I have 8 things, so I'm good. Okay, Y list, same thing. Start with the squiggly braces. Numbers separated by commas. 74, 76, 82, 81, 76, 95, 88, 89. You can hit enter a couple times and your answer pops up. So my M is 1.611. Remember, just chop it off after 3. Your B, 74.969. So when I write it as an equation, y equals mx plus b, y equals, plug in your m right here, 1.611x plus 74.969. That's what we did last time. But our calculator tells us more than just the M and the B. You see there's other stuff here? We're going to use some of that today. So first up, the correlation coefficient. So our definition for correlation coefficient is the number that tells you how close the data is to the line of best fit. So for this, we're going to look at this chart. I'm going to flip a couple pages here. So on page 19, here is our chart that explains how this works. So our correlation coefficient is going to be anywhere from -1 to +1. Okay, if it equals exactly -1, that is a perfect negative. So 1 is perfect. If it's a -1, it's perfect negative. If it's a +1, it's still perfect, but it's perfect positive. And then these other ones. If it is anywhere in between those two values, it's going to be a strong negative. Okay, so anywhere from -0.8 all the way up to -0.9. Same thing here. If it's anywhere in between those values, 0.8 and 1, but this time positive, it's going to be strong. Okay? If it's anywhere in between 0.8 and 0.3, I didn't draw that line very well. It's going to be weak. Same thing here. 0.8 to 0.3, it's going to be weak. And then if it's anywhere in between the 0.3s, so 0.29 to -0.29, we're going to call it no correlation. So I'm going to write that a different way down here at the bottom. Okay? So we had -1, -0.8, -0.3, 0, +0.3, +0.8, whoops, no decimal there, +1. So this one right here, if you are exactly that, you are perfect. And if you are exactly here, you are perfect. Okay? If you're somewhere, I'm going to do it this way, I think, in between those two, that is strong. If you're somewhere in between those two, it is weak. Same thing here. If you're somewhere in between those two, you are strong. If you're somewhere in between those two, you are weak. And if you're anywhere in this range here, you have so little correlation, and we call it no correlation. Okay? So this is kind of our gauge. So you need to remember the 0.3 and the 0.8 as kind of our cutoffs. So we had our calculator. we had this information. What is the correlation coefficient? Well, it's actually our R. Not R squared. You'll use that in Algebra 2, just the R. So for this one, for this data, what was our correlation coefficient? Our R was 0.774. Remember, we chop off after 3 decimals in Algebra 1? So where does 0.774 fit in our data? So remember, we're using this scale here. So first off, strong or weak, and then positive or negative. So 0.7 is between these two. That means it's going to be, sorry, I'm not on the screen here. 0.7 is between these. Remember, anything bigger than 0.8 is strong, less than 0.8 is weak. So we are going to be weak. Then, is it positive or negative? Well, it's a positive number, so it is a weak positive. Why is it a weak positive? Because it's between 0.8 and 0.3. So what does it tell us? Well, if it's weak, that means there's some correlation. Yes, the points all kind of tend to go on a line, but they don't make a perfect line. So it is weak, and the correlation coefficient tells us that the data is somewhat close to the line. It's not a great line of best fit, but it's not a terrible one either. At least we have weak correlation. Sometimes we'll have no correlation, then it's a horrible fit. It's just okay. All right, so let's try the same thing again. We have example 2, example 3, and example 4. We're going to go through, we're going to plug each of these in, and we're going to find the correlation coefficient. So we've already done the writing the equation part. This is the same one that we did in our notes last class. The only new part is finding the correlation coefficient. So I want you to pause the video, try to do these on your own, see how you do. This one's set up a little differently. Try it. If you don't know what it is, go ahead and keep watching. All right, so first up, because this is a mapping, I'm going to go ahead and turn it into a table so that I know exactly which points I'm putting in where. Okay, first point is the point 2, 5, 3, 6, 4, 7, 5, 7, 8, 8, 9, 7, 10, 9. So every time, home, new docs, don't save, add a calculator, menu, stat, calc, mx plus b. Again, if you're struggling with this part of how to type it in your calculator, go back and watch the 1-2 notes. They're going to help you a lot. Squiggly braces. Type in your list. Type in your Y list. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Got them. Okay. Find your equation. Make sure I'm using the same format, same colors. So y equals, take my m, 0.356x plus my b, 4.910. Strong or weak? How do we know? So this r value was 0.865. So again, go back and look at your table. 0.86, so that's right here. Going to be between 0.8 and 1. Therefore, it is strong. So this is a strong positive because it is between 0.8 and 1. All right, example 3. Same thing. This time it gave us the table. Let's go ahead and type it in. Menu, stat calc, mx plus b, braces. Now this one we haven't done before, so you can't just look back. Braces. Oh, well, I don't have decimals this time. This one looks a little different. Let's see what happens. Y equals mx plus b. So y equals, my m was 1, x plus b, which is 4. If you want, remember you can write it without the x. Y equals x plus 4. Because the 1, remember you don't have to write a 1 out in front. Either way is fine. What's the correlation coefficient? So this time my R is 1. So what did we say a 1 was? If you have exactly 1, it is perfect. So this is a perfect. And because it's positive, it is a perfect positive. Because my R is exactly 1. Okay, now let's graph this real quick. Let's look at what it looks like. So I'm going to plot these points here. 1, 5, 2, 6. Whoops, I didn't plot them right. You know that's right. 3, 7. 4, 8, 5, 9, 6, 10, and then 10, 14. Do you see how these points perfectly line up on a line? I could draw my line through there. I could draw a perfect line through these points. See my wonderful ID here. You see how that line perfectly goes through all of those points. That's why we call this perfect correlation. When I go back and look at this one, I can't draw a perfect line that goes through all of these points. That's why this was weak correlation. Okay? All right, is the data discrete or continuous? So, this is the part everybody misses, the word data. The data are these points right here. It's these pink dots I have. So, is the data discrete or continuous? The dots are discrete because they are dots. So, that's review from section 1.1. Predict how many minutes Jason can stay on his skateboard after a year. So, remember, there's two ways to do your prediction. You can take your equation, y equals x plus 4, and I can plug in right there. I can plug in 4 after a year, so how many days is that going to be? 365 days. So 365 plus 4. $369 days. Or the shortcut, if you remember that, is to use F1. So if I type an F in my calculator, notice how it's an italicized script F. As soon as I hit the number 1, they both go regular font and bolded. That means I have a function saved there. I want to evaluate the function for 365 days. So F1 of 365, same answer. So you can do it either way. You can plug it into the equation or you can use the F1. All right, last one. The data shows the number of miles you drive versus the amount of gas in your tank. So find the equation for line of best fit. I'm going to go ahead and plot these first. Let's see what it looks like. So 0, 15, 10, 14.5 is right about there. 20 is 14. 30 is 13.5. 40 is 13. Those look like they're making a pretty straight line. Let's plug it in and see. Menu, oops, I forgot. Home screen, new docs. Don't save. Add a calculator. Menu, stat, stat calc, mx plus b, squiggly braces. Okay, again, y list, squiggly braces. Hit enter a couple times. All right, so let's fill it out. Y equals mx plus b. So my m this time was negative 0.05. And my b was 15. Correlation coefficient. Remember, that is your r. Not r squared, r. It was -1. So first off, this is the first one I've had that's been negative. So it's going to be a negative correlation. And if you look back over here, if it's a 1, remember it's perfect. So this is a perfect negative correlation. Why? Because r equals -1. Is the data discrete or continuous? So again, we're talking the data, not the line, the data. The data right here is points, so it is discrete because it is dots. Okay, if I wanted to graph this line, my y-intercept is 15. I'd start right here, and I'd go down 0.05 for every mile. Now that's going to be really hard to calculate here, but we knew it was perfect. So we can actually draw a perfect line through these points. Okay, predict how many gallons of gas you'll have after driving 250 miles. I want to do the shortcut on this one. So remember, you can plug it into your equation, or you can use F1. F1 of 250. I'm going to type that in. F1 of 250. I have 2.5 gallons left. All right, so the big thing to remember from this lesson is the scale right here. These are your big key numbers. So if it's between 0.8 and 1, either positive or negative, it's going to be strong. If it's between 0.8 and 0.3, either positive or negative, it's going to be weak. And if it's anywhere between the 0.3s, including 0, we're going to say no correlation. Okay?